Okay, hi everyone. So in this tutorial, I'm going to show you how to build from scratch like a simple version of the Touch Designer file that we used in class, which can be used to control the robotic arm in real time. So this is the whole network. I've removed sort of some of the more complex things, and I think this is nice and neat, and it contains all the limits we need to use the robot in real time safely. So you can see here I've just got like a random, or not random, like a LFO, low frequency oscillator, just sending signals to all three axes. If I just quickly sort of replace those with these constants, I'll just have to delete that connection. Then you'll see what we've got here is just basically a XYZ controller for the robot arm. And that's what we're going to make today. Just something nice and simple that sends the correct data to the robot out here from this OSC out chop. And also we'll make a little visualizing system that will give us the approximate, well, a pretty close indication of the working area. And also, showing us the height of the table. So if we go all the way down, we'll know kind of how close the tip of our tool control point, our TCP of the robot is to the table. So it kind of gives you a nice little preview. And I hope that going through this process of building this, it hopefully shouldn't take too long, but the purpose of this is so that you will understand from the ground up how to make this, and therefore it might give you ideas for how to make other types of interactive systems to work with the robot arm that you might use in your projects or just your studio experiments. Okay, so let's jump in. Now, the first thing we need to look at is just our range. So the way that I've made this Touch Designer network is I've normalized all the values on the Touch Designer side so that our LFO or our constant, when it moves, let's say on this axis from -1 to 1, that's the full range, and then we convert that into the millimeter ranges that the robot needs to see. So these ones on the right, we can't change because that's in real space, the working limit of our robot, at least in real time. I've left a little bit of space. You could probably go another centimeter or two, but we don't want the robot to shut down in the middle of one of our artworks. So I've tried to keep this pretty safe. So 200 millimeters high down to -10, 300 millimeters in either direction, and this range of 250 millimeters, which is kind of close to the base of the robot, then stretching out 550 millimeters. But what we'll see on the Touch Designer side with our signals is just a nice clean range between -1 and 1 for our two horizontal coordinates, and then I just used 0 and 1 for the height, just with the idea that 0 is kind of the table. I thought that was kind of simple enough. Okay, so let's go into Touch Designer, and right, I'll just pop this over here. I might have to refer to that original one a little bit, just because some of the settings are important. But this is our new project. Just a quick reminder. You can either, in Touch Designer, you can create a new project folder, and that will create a proper directory for all of your files, or you might already have that, and we'll go over that in class, but you want to have a project folder with subfolders for all of the other things you're going to use in class, like images, videos, sounds, just having them in a nice directory. So start your new file, you can make your new project, save your project. So I'm going to just actually save this as, and I'll put it into I've already got a project directory in my teaching folder, object technology, project files, Touch Designer, project files, and I'll call this week 1 robot tutorial. You can call yours something different, just depending on what you use it for. Okay. All right, so let's get started. I'm actually going to start at the end. I'm going to start with our output. If I double click, I'm going to go into chops, and I'm going to grab OSC. I've just typed that in up here to filter my results. OSC out. So if I just pop that here, this is the thing that's going to send our messages to the robot. if I just grab a constant, at the moment it's got nothing going into it, but if I just grab a constant and connect this here, you know, that will be our OSC out. I can make this number, you know, whatever we wanted. The OSC out has a few parameters that we need to have set up correctly. So if we have a look here, we need to change from localhost to 127.0.0.1. And then we need to set the network port to 12345. These are just the setting. Excuse me. These are just the settings that the Python script that we're using to talk to our robot are looking for. I'll turn the maximum queue size to 0. I will leave cook every frame on. Float 32-bit is fine. I need to go from time slice to transpose, and then send rate, turn that off, and send events every cook, turn that off. So that's just the same settings that I have in my original Touch Designer file. So they're the ones we're going to keep, and that should work no problem. Okay, so if we sent this at the moment, it wouldn't work at all for our robot. Our robot actually needs to see 3 different values for the 3 axes that we're moving it on, and these values have to have the correct name. So as an example, one of them needs to be called position, and if I just copy and paste this, the other one needs to be called translate Y, and connect that. Aha, okay, I need to add a merge, sorry, lol. Okay, I need to just add a merge chop, because I need to bring all of these together. So we've got our position, our translate Y, and now that's going to our OSC, that's better. And that'll just copy and paste that constant, and then this would be our translate Z. Now you'll notice that instead of having translate X, translate Y, translate Z, one of them is called position and the other one is called translate Y and translate Z. Now that's just following this. You can see I've labeled them here. That's just going back to the Python library that drives the robot. That's how they've written it, so that's what we have to send it. Simple as that, but they're all labeled here. Okay, so if we connected this straight away to our robot, that should be working now, as long as there's no spelling mistakes, position, translate Y, translate Z. The only thing we need to check is our ranges. So if we looked here, and I sort of bring these both on the screen at the same time, I'll zoom out on that a little bit so we can have a look at both. Okay, so we can see that the translate Z, that needs to be somewhere in between 200 and -10, which it is. Okay, can I drag that across a little bit more? Okay, that's better. The translate Y needs to be in between -300 and 300, so that technically will be fine. But the position wouldn't be fine. That'll be out of range. That needs to be minimum 250 and maximum 550. So I could put the position here and just put it at, like, you know, I don't know, 300. And then all of a sudden this would actually work if we put this straight into the robot. But you can see it's a bit risky, right? Like we'd really have to be looking at this picture here to know what we're doing. And also we could quite easily send our numbers out of range, which we don't want to do as well. So what we're going to do here is we're going to work backwards and sort of put in some limits that will stop our numbers from ever going outside of these ranges. So for example, even if we make a mistake earlier on, we can always make sure that the number that comes out here can never go outside these ranges. So I'm just going to sort of, and this is a weird way to build a Touch Designer network, to build it backwards, but it kind of makes sense to me because we're really thinking about what the robot sees, and we already know what it needs. It needs numbers in this range. So that's what we're going to start with and just work our way back. So okay, so what I'm going to insert here is going to be a limit. And the limit is I'm just going to set that range. So I'll set it to clamp. And this is the position. It's the top one up here. So the positions limit is maximum of 550 and a minimum of 250. Okay, so that limit's there. Great. So let's do the other here. I'm going to right-click on the just right-click on the connection line and insert operator limit. And so what's the The limit we need for the translate y, this is our translate y, is going to be minus 300 and 300. So we'll clamp that at minus 300 minimum and maximum 300. That's good. And then we're going to do the same thing for the translate z. Insert the operator, put in the limit, and have that clamped at minimum minus 5 is what I've got here. Oh no, minus 10, sorry. Minus 10 and maximum 200. Okay. So I think that's all correct. Yep, looks good to me. All right, so some other things that we could actually accidentally get wrong. Let's say, you know, I wanted to have like an LFO giving us kind of a number moving back and forth instead of this constant, and I pop this into the limit. Well, the first problem is, okay, we're way out of range, so we're just staying at that 250, but you'll also see the name has changed. It's now just Chan1, and that's no good. If we send a Chan1 here, our Python script won't know what to do, and it might crash the robot. You know, it might just send a null value. It'll probably do something we don't want to do. We always want to make sure that this OSC out is sending numbers in this range. So what I'm going to do here is I'm going to insert a rename, which will make sure that no matter what is coming in here, it's always going to be coming out as, in this case, position. So now we're back to position and then translate translate y and translate z. So let's do that for the others. We're just going to sort of build this kind of clean habit of putting in these little things that check that no matter what's coming in, what's going out is what we need it to be. So I'll put in our rename here. Now I'm just going to be a little bit obsessive. I'm going to put these, just because it's the way I did it in my first file, I'm going to put the renames at the end. It doesn't really make a difference. It's just, I'm sort of copying the one that I made and tested, and I just want to keep them the same, just because it's easier to avoid mistakes. So this one's going to be called position, and I'll drop this one in here, insert operator, position, oh no, sorry, rename, pop that there, right click here, rename, pop that there, and so, okay, this one is renaming to position, this little asterisk, that will basically just, it'll just grab whatever's coming in. We could select the translate Y, but just leaving it at asterisk, I think that'll just mean it'll just grab whatever name's coming in and rename it to what we want. So we want this to come out as translate Y. Translate Y. And now you'll need to be very careful with your spelling here. If you make a spelling mistake, again, it'll send the wrong thing out, and the robot will probably crash into the table or do something we don't want it to do. So please be very careful with your spelling. And you can always check if you've made a mistake by just looking at the OSC out and making sure that position, translate Y, and translate Z are spelled correctly, are in that order, 1, 2, 3, and are in that that number range that we have over here. Okay, so let's do this last rename to translate Z. Okay, cool. Okay, we're getting through it. All right, so what we're going to do, I'll just delete that LFO at the moment. That's kind of not needed. All right, so I'm going to make a little bit more space here. And the next thing I'm going to do is I'm going to add in okay, yeah, we're going to make the visualizer now, and then we're going to come back to one more operation here, but we're getting there. Okay, so these constants here, I'm going to have them all just be between like 0 and 1, as I said before. Maybe I'll put this at 0.5, or sorry, not necessarily 0 and 1. They could also be, should be more like this. Position will be position and translate Y will be 0 and 1, and then translate Z will be just going between 0. Sorry, let me say all of that again. Position will be -1 to 1, translate Y will be -1 to 1, and translate Z, the height, will just be 0 and 1. Okay, all right, so what that also means, so we're going to, I'm just going to add in, and maybe I'll just add a little null here to mark off this is going to be a different workspace. this is where we're going to create the values that we're going to use for our little visualizer. I'm going to send our visualizer out from here. All right, so I also want to put some limits here to make sure we stay between either 0 and 1 and -1 and 1. So I'm going to put these limits here. Limits here. Okay, all right. So our first two limits should be -1 and 1. So let's clamp this at -1 and 1. That's good. Clamp, -1 and 1. And then we're going to clamp this one at 0 and 1. So what that basically just means is that for the purpose of our visualizer, no matter what we put in here, we also want it to stay within a range, because we want to have a range locked for our visualizer. And then just to double check, we're going to have a range locked for our OSC out. And I think that should mean that we can really be a bit more experimental with our signals, knowing that we've put these limits here so that in the real world, we shouldn't do anything crazy to the robot. Okay, so I'm just going to use the full screen again, and I'm going to split my screen by just clicking here. So this is your pane layouts if you sort of need two spaces. And what we're going to do is I'm going to create that little visualizer I showed you before. So we need to set up a little render network. I'm going to double click, and I'm going to go into components, and I'm going to grab a camera, put that down here, and a light, put that here, and a render top. Okay, so that's all ready to see some geometry, and that's already made its little automatic connection. So the first thing I'm going to put in will be, okay, I'll put in the table. I'm going to get a box in SOPs. A box is basically just a cube, and then I'm going to connect it to a transform. When I'm making these connections here, I'm just pressing middle mouse button here as just a shortcut. Okay, so I've got that transform, and then I'm going to put that to, I guess, a null, because I might have to do a few more things to it. And then I'll put that to a geometry. All right, I'll just press P to hide that. So you can see now the geometry is being read by the render network. And if I go into my second panel and I click this drop down here, I'm going to go into geometry viewer. And we can see now if I left click will give us our rotation, right click will allow us to pan. This is the box I've just put in here, and there's my camera and everything else. Okay, so that's all good. Now, I'm just going to copy a few settings on the position of the table, because I had to go down into the robot lab and just work out where the visualizer should be in relation to where the real robot is and the numbers we're sending it. So I'm just going to give you some numbers here for both the size of the table and the position of the table, because they're a bit kind of, I don't know, arbitrary. They're not things you can guess. Okay, so in that transform coming out of the box, I'll press P, and I've got a weird translate here. This is probably not doing much, but minus 0.01, I've got minus 0.59, and I've got 1.32. So I've just sort of moved this a little bit around in space. The scale on the X, I've got 2. On the Y, I've got 0.1. And on the Z, I've got 2.15. Okay, so that's going to be the size of our table. The other thing I did is I made like a little checker box texture for the table. The only reason I find that useful is when you're looking at where the robot's moving, the checker box, it just it makes it a little bit easier to see where you are. So, you know, let's make that texture. It's pretty easy. So we'll just go into tops. Going to grab a constant, and we can make it really small. Like, how small should I make it? Like 10 pixels by 10 pixels. Okay, and we can, I don't know, grab another one, copy and paste that, and I can make this one black. And I'm going to get a fit, and I'm going to make this fit, let's go like 20 by 10, and then I will put my transform, translate, and I'll just move the cube over I guess 0.25, is that going to do it? Yeah, 0.25. And then I'm just going to copy and paste that fit, but I'm going to put this constant in it, and I'm going to make that a positive 0.25. So now I've got the white on one side, the black on another, and then I'll grab an over. I'm just making a checkerboard pattern. And I'm going to join these both together, and there we've got a black and a white square. And then I'm just going to do the exact same thing again. So I'm just going to grab a fit, and this time I'll make it 20 by 20, 20 by 20, and on the y-axis it'll be 0.25 up there. I'll copy and paste that and make this one negative, and then we'll just bring in another over, and we'll just composite them back together. And I need to flip one of them, so I'll make the scale on the x-axis on this one -1. Okay, so there's our checkerboard. And then we can just make it sort of repeat by putting in a crop. And we just need to change a few settings on the crop. If we just make that 10 and that 10, now we've got this kind of repeating checkerboard pattern. And I'll just pop that out to a null, and there's our texture. Okay. And you know, it's fun kind of making these little textures of your own. It just means that your Touch Designer file, it doesn't need an external file. You know, you could download a checkerboard pattern, but I don't know, that's just going to make your file a little bit heavier for no reason. It's much easier for your computer just to make the checkerboard pattern. It's a very small amount of data. Okay, so now if I just drag this null onto the geo, oops, sorry, no, that's not right. I missed a step. I need to make a material first. I'll just put a constant material here, drag the null onto the constant. Oops, that was the wrong connection. Drag the null onto the constant and click color. And now drag the constant onto the geo and click material. Okay, so now I've got a checkerboard table. Good. So what I want to do now is make a shape that represents the end of the robot. So, you know, where our movement is occurring. This is sort of important part. So I'll move my table down, and I might just put my render network sort of off, put that out the front here, make it nice and tidy. Okay, and now let's make another shape for the robot TCP, or the end of the robot. So let's double click, let's go to SOPs, and we're going to grab a tube. Grab a tube, and we'll put in a transform. I think we're going to need a few transforms actually. 2 or 3, we'll work it out. I've got 3 in my original. I can't remember if they're all necessary, but we will find out. Pop that out to a null. Okay, and then that needs to also go to a geometry. Good. Okay, so there's our tube. And I'll just right click. I'm just going to bring these back so our geos are in line. I just like things to be nice and neat. And then also let's just make a material. I'll put on I don't know, maybe I'll put on a phong this time, and I'll give it a color, make it this nice teal color, and then I'll just drag that on to our material. There we go. And now I just want to alter that tube a little bit. First of all, in the tube, I need to go to the tube itself. Radius number 1, which one do I want? No, I want the other one. Okay, so I'll put that at 1, and I'll just drag this down till it gets nice and small, till it makes like a point. And I'll drag the other one down a little bit. With my middle mouse, I'm just going to select the increment until I can sort of get a nice shape. You can have this shape be kind of what you like, but maybe I'll still use the settings from my previous file just in case you know, there's any other things that specifically needed. It actually might need to be a specific size just so visually it matches up with the visualizer we've made. So let me just copy my settings. So I had that at pretty close at 0.2, and whoops, what have I done there? Radius at 0.2, and then I had the other radius at 0.01. That's fine. I think all the other properties were left the same. Then in the first transform, I just put the scale of everything down to 0.6. So I'll just do that. Okay, so there's my robot head. And then in the next transform, I think I just moved it into position. So I had this at 1.3, and that is just, I guess, like kind of in the middle of our table. So that kind of makes sense to me. And then this transform, this is where we're going to connect the information from our nulls here to move our visualizer. Okay? So to do that, it's pretty straightforward. If I press P and open up my parameter window here, I might just make my palette a bit smaller. So these are the parameters on the transform for this cone here. And if I just make these active, 1, 2, 3, I just need to check that they're sort of, each one's going to the right place, because there's a little bit of Touch Designer trickiness here. So this one, the top one, which we're using for position, that will go into our, I believe it's our TX. So I'm going to drag this over and I'm going to say chop reference. I'll just open it up there. That should be our TX. The second one, which is our TY, is actually going to go into our Z, chop reference. And the reason for this is that if you look in Touch Designer, it's a little funny. Touch Designer names the vertical axis Y and the depth axis Z, and then the other sort of length axis X, whereas the robot and many other softwares have the vertical axis as Z. So that's why we put that little swap. So then our third null here, which will be our height, that's actually going into TY, because that's our height, so chop reference. Okay, there's one other little trick that we need to do, and this is really just because of the direction that the robot is facing, but I'll just check our constants. This should work fine now. So now if I move my constant here, and my constant here, and my constant here, we've got the visualizer going from whatever the numbers we're putting in here are going out to our visualizer down here, but at the same time they're being mapped to the right values for the robot. Okay. I mean, the other way we could do this is we could make an enormous, like a really large scene where we're using these exact numbers, but I think that would probably have its own issues. It's much easier just to work here in values between -1, 1, and 0, and then just do the mapping for the robot there. Now, when I was testing this in the lab, I found that just to make sure that we're facing the correct direction, we actually have to invert a couple of these numbers. So the first thing we need to do is I need to go back down to this transform here, and TX we actually have to multiply by -1. Just trust me on that one. And T our second one here, which remind me, which one's this? This is our position, I think, which starts our depth, our moving away from the robot box. That one, what have I done? I think I've also multiplied that by -1 here. Multiply this by -1. Okay. All right. So now, so I think that still looks right. So now we go like that, and like that, and like that. I'm just going to have a little check that everything here functions the same way as my original network. Okay, I think that looks pretty good. Now, what we're also going to do is I'm going to add in a little box here that represents where the robot is attached to the table, just so we don't get confused as to, you know, which way we're facing. So we're just going to add in one more piece of geometry. We can actually use the same box. We've got a box here, so I'm just going to add a transform. I'm going to grab that box, and I'm going to add a null and add a geo. Okay, so there's our other box. And then I'm just going to copy some of my transforms here. So what have I got in my original? So I tried to have it reasonably close to the real thing. What have we got here? We've got 1.41 minus 0.27 and 1.32. And then the size I just put down uniformly to 0.5. Okay, so that's our robot controller. That's our table. I think in my original one, just to be cute, I also added in like a little cylinder to show us where the top of the robot is. I don't know, it's totally pointless, but we can do that as well. I don't know, good bit of practice for using geometry in Touch Designer. So what we're going to do is we're going to grab the tube, and actually I'm going to throw this merge in here. Sorry, merge, put that there, connect that to there. So now, oop, that didn't work. Hold on. Right click, drag. Okay, so I'm going to connect that to there. Why is that not connecting? Merge. There we go. Okay, so now I've got my tube in there as well. Let me just have a look at the tube itself, go into the details, turn on the end caps, and then I'll just copy my same transform settings over just to save us some time. 1.41, 0.09, 1.31, and a scale of 0.15. Okay, so that's our robot. That's the base of the robot. That's the end of the robot. You could make a whole robot if you wanted. Rigging that's kind of fun. I've done it before. It's a little bit time consuming, but if that's what you're into. Okay, and hey, let's add a color. Let's grab another phone, chuck it there, pick a color for the box, maybe a nice soft yellow. Turn the value down, saturation down, there we go. Kind of not the nicest yellow, but okay, drag that on, material. Okay, all right, so we're getting, we're almost done, to be honest. We're pretty close. I just want to do a few more checks. Now, what we're going to need to do is we need to still math this range to make sure we're getting to the right range for the robot. So we've got our limits, but we're not actually converting that. If I go back to this this diagram here, we're not actually converting this to this yet. We're just kind of clamping it or mapping it. We need to make sure that a number moving between here and here is smoothly mapping to this range here. So let's just do that. So what that means is we're going to add a math for each of these. Math and math. Hath. All of the importance of spelling, and I typed math wrong. Okay, and we've added a math for each, and we just want to match up the ranges. So the first math here should be, to remind us, I can sort of squidge this over and bring back our little diagram here. So the first one is going to be, if I bring my parameter window up, it's going to be going from -1 to 1 to -300. Oh no, sorry, I'm looking at the wrong one. -1 to 1, we are actually looking here. So it should be going 250 to 550, because that is our position. Let's just check that. So this is the one we've renamed to position, and the range for position is 550 and 250. Okay, so the next one is translate Y. Our range for translate Y is -300 to 300. So let's go to that math, press P to bring up the parameters, go into range, -1 to 1, and -300 to 300. Okay, and then our final one is a range. Remember, this one stays at 0 to 1, just because I think 0 for like a 0 height of the table kind of makes sense. -1 to me feels like we're going through the table, so I just kind of did it that way. Okay, so that's going from 0 to 1 to a range of -10 to 200. Okay, so now what that should mean is, if we just do some really simple controlling, I'll just double click this to see more of the screen. If we do some simple controlling from these constants and I just drag here, it's not going outside, drag here, not going outside, and drag here. All looks pretty good. Now we might, once we're connected to the robots, there might be some fine tuning here, but I think we can do some cool stuff like, if I grab now like a mouse input and I've got an X and a Y, coming from my screen space, well, all I need to do is select the X, select which one we need. So I might copy and paste that. So here, if I do this one, and I just want to select the X here and select the Y here, now I've got two numbers. And we can look at the range, it is kind of a -1 and 1 type of situation. So our existing mapping for the screen space should already be pretty good. So, hell, we might even do something nice like put a null in here, just so that everything we do on this side, we can just reconnect to those nulls. That's a kind of a nice way to work. So if I put this here and I want to do our X and Y mouse to the robot, well, I should just be able to do this and this, whoops. And now nothing's happening. Okay, that's kind of interesting. Why is nothing happening? We're not getting any movement here. What's wrong? -1. Wait, is it our... okay. Yep, okay, so this is interesting. We also need to put a rename in here because it's still looking for the old names. Okay, and that's just because I did this chop reference rather than export chop, but I did that so I can still kind of change my expressions by doing that. Okay, so that's a good little mistake to find. Let's just put in another rename here. I mean, having the renames here and at the end is not really needed, because if they've been renamed here, they'll be renamed later. But I'm just going to leave them both in there because, yeah, it's, having a little bit of redundant safety could be nice. So the first one should be called position. So let's do that. Let's call this one position. And I believe the second one should be translate Y. So let's call this translate Y. Now, is that going to fix it? Hey, it looks like it has. Okay. So if I zoom out a bit, yeah. Okay, so that's working now. Okay, cool. Well, that was a nice little mistake to find, because then we can sort of add in more things. And you'll notice here what we don't have is any control for height. We could either, I'm not going to add anything more in here. This is where you can just experiment in Touch Designer. You could add a keyboard in that starts to add numbers to the height. You could add an LFO. You could do all sorts of stuff. But I think this is enough so that you've at least built up a system where you've got the correct numbers going out to the robot that are clamped. You've got a visualizer that shows you where you're looking. And if you hover over the geometry viewer and you press like 1, 2, 3, 4, 5, 5 will give you this kind of orthographic view, which is pretty useful. So like if I drag here, I can kind of see exactly where I am. So that's also kind of cool. Okay, and the final thing we can do is, if we're doing something like using a mouse input, like what I've got here, mouse input can be a little annoying if we're in the network viewer, because if I move my mouse like into different parts. It might not track accurately when we're moving over different bits of the touch designer interface. So we can always just look at this in performance mode. If we press performance mode now, we'll get a black screen. That's just because we haven't added an out here. So if I just grab an OUT out, pop that in there. If I press play now, we've got our viewer and we can move our mouse freely. The only thing we might do is we might kind of, move the camera a little bit so we've got a slightly better view. So if I just click that as active, and I might just, with my left button, rotate it and just have it something that sort of matches like a view that's something we're going to work with. We could even do something nice and, composite multiple cameras with a top, front and side like that. That could be cool. But again, that's something we can get into a little bit later. I just want to keep this not too complex. So now if I press play, that's what our network's doing, and that should be sending straight out to the robot. Okay, great. See you soon.